Ladies and gentlemen, welcome to your friendly chemistry class. So what we are going to study today is chapter 12, which is about organic chemistry. Now, definition of organic chemistry is compounds of carbons. So, pardon me. So if I go to compounds of carbon, let me adjust my pen and go to pen and see if my pen is writing. I don't know why my pen is not writing. Now let's see if pen is writing. Yes. Okay. So if you're talking about alkanes, they are compounds of carbon, and in particular, name for this family is hydrocarbons. That means they are composed of carbon and hydrogen. So in alkane, we have only saturated hydrocarbons. What is saturated hydrocarbons? It means saturated hydrocarbons. It means you only have single bond between carbon and hydrogen and carbon and carbon. If you have double bond or triple bond between number of atoms of carbon, you are going to have unsaturated hydrocarbons. So there is a relationship between number of hydrogens and number of carbons. For example, if I look at the simplest hydrocarbon, which is methane, you see you have one carbon and 4 hydrogens. So if you want to calculate number of the hydrogens, all you have to do, take number of carbons multiplied by 2, which is 2, and add to it, you get a number of 4. So you know number of hydrogen. If you have one carbon, you are going to have 4 hydrogens. Or if you have 3 carbons, take number of carbons. This is 3 carbons, and I don't know how many hydrogens I need. Take number of 3 multiplied by 2 and add 2, you are going to have 8. So if you have 3 carbons, you're supposed to have 8 hydrogens. And what if you have structure of C6, how many H? You can take number of carbons, which is 6, multiplied by 2 and add 2, you are going to get 14. So if there are 6 carbons, you have got 14 atoms of hydrogen. That's the molecular formula. We call all of these molecular formula of alkane. So this is molecular formula. And if I go to the next slide, here we want to define a structural formula. Structural formula shows the arrangement of atoms in a compound. For example, if I have, let's say, 3 carbons connected together, and these 3 carbons, one of them is going to have 3 hydrogens, the middle one is going to have 2 hydrogens, the end carbon is going to have 3 hydrogens. The way we decide how many hydrogen is needed for each carbon is to make sure every carbon is connected to 4 bonds. That's how we know. If there is no bond between carbon and carbon, you place a hydrogen. There is no bond between carbon and carbon here. Hydrogen, 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 and hydrogen. So this is one way I can show the structure of an alkane with 3 carbons. The name of this compound is propane. But I can also show the molecular formula, which is 3 carbons, 3 times 2 is 6, and add 2, 8. C3H8 is also molecular formula of this compound. Another way that I can show structure of propane is to do this. Instead of writing 3 hydrogens on a carbon, I can write CH3, and then next I have got CH2. I place a CH2 here, and next is CH3. So this method of presentation of a structure is condenser structure. You only show the bond between carbon and carbon. You do not show the bond between carbon and hydrogens. If you show the bonds between carbon and hydrogen and carbon and carbon, then you're really showing the expanded structure. This is, sorry, let me go back and go back again, and I want to change the color of my pen. So I open this, I am in the pen, and let's change the color to a blue color. So this form of showing the structure where all the bonds of hydrogen and carbon are shown, we call this expanded structure. And the structural formula of the compound are both of these. One of them is expanded structural formula. The other one is condensed. This is condensed structural formula. And this is molecular formula, which shows total number of atoms in this hydrocarbon. Molecular formula. So, do you see in this carbon we have got 4 bonds. Carbon is the tetravalent atom. You always make sure there are 4 bonds on each carbon, which amounts to 8 electrons. And if I have only 3 hydrogens, the other bond is open for attachment to another atom of carbon. If I have a carbon between 2 other carbons, let's say a carbon is here and a carbon is here, because 2 of the bonds are used already for bonding with adjacent carbons, then I'll have 2 hydrogens, 2 bonds to 2 hydrogens. Now, we can also show organic molecules in the form of line bond atoms. For example, this compound on the left has got 6 carbons, and actually we call this hexane, hex for 6. Do you remember at some point we said if you have an atom of carbon which is connected to 4 bonds, 1, 2, 3, 4, or any central atom which is connected to 4 bonds, is going to have tetrahedral structure. That means the angle between the atoms, between hydrogen and carbon-carbon bond, and the bond, the angle of the bonds between the carbon-carbon bond, they are all tetrahedral, so these angles are 109.5. This is 109.5. This is 109.5. This one is 109.5. So if I want to show the structure of hexane, it's not really looking like a line where the angle is 180, but the angle between the bond are 109.5. So do you see, if we make these structure of alkanes, actually they look like a zigzag structures. So 1 carbon here, another carbon, 2, 3 carbon, 4, 5, 6 carbons is called hexane. So number of carbon is 6, number of hydrogen is double number of carbon, which is 6 times 2, and add 2 is going to be 14. That is the structure of hexane. So if we show line bond formula, you can show every atom of carbon as a point. Connect these points with 109.5 angle, then you get line bond structure of the alkanes. So let's look at the summary of the formulas that we can use to show alkane. This compound is methane. It's a natural gas. It is really one carbon connected to 4 hydrogens. The expanded structure shows 4 CH bonds. Condenser structure, we do not show CH bond, so it's CH4. And molecular formula is also showing there is 1 carbon and 4 hydrogens. Now, if I look at the structure of ethane, where it has got 2 carbons and 6 hydrogens, I can write the expanded structure, 2 carbons connected with 4 bonds. So I place 4 bonds here. And then when there is no carbon-carbon bond, I place a hydrogen. So there is no carbon-carbon bond on this location. I have a hydrogen, hydrogen here, hydrogen here, hydrogen here, hydrogen here, and hydrogen here. So this is the expanded structure of ethane, which has got 2 carbons. And for condensed formula, we show only carbon-carbon bond. We do not show the carbon-hydrogen bonds. This is the molecular formula of propane. Prop shows 3 carbons. 3 times 2 is 6. Add 2, you get 8. So the molecular formula is C3H8. And if I want to show the expanded structure, I have got 3 carbons. I make sure I have 4 bonds on each carbon. And then I show CH bond. Where there is no carbon-carbon bond, there must be hydrogen sitting. Here, carbon-carbon bond, and then I have got 2 hydrogens. And on this carbon, there is 1 bond to carbon, so I'm going to have 3 hydrogens here. And if I'm going to show the line bond, I have 3 carbons, 1 carbon, 2 carbon, 3 carbons. Connect them together. And this is actually showing the geometry of the expanded structure, and the line bond formula is 3 dots connected together with 109.5 degrees. Okay, so in order to use a systematic nomenclature where every scientist around the world is going to name the same compound with the same name, there is a set of rules which is called International Union of Pure and Applied Chemistry. And essentially, every chemist is using this method. So there is no confusion between the chemists from different countries. So they have same systematic name. Now, systematic name for alkanes, if you have saturated hydrocarbons, which are called alkane, the name must end up with A and E. So if it is methane, 1 carbon met, ane at the end, methane, 2 carbons et, ane at the end, ethane. So methane for 1 carbon, ethane for 2 carbons, propane for 3 carbons, butane for 4 carbons. They all have A and E at the end. A and E at the end. A and E at the end. So generally what we use Greek prefixes such as pent for 5 and hex for 6. And then we add A and E at the end. So hexane is hex plus A and E. So this is the formula of hexane, C6H14, which is 6 times 2, 12. Add another 2, you get 14. All right, so this is a table which shows the Greek prefixes that we use for number of carbons. Met for 1, et for 2, prop for 3, like propane that we use for making barbecue. And for 4 it's bute, so the hydrocarbon, the alkane of bute is going to be butane. Oh, sorry. Let me go back. Okay. And then pent for pentane, hex for hexane, 7-hept. Heptane is an alkane which has got 7 atoms of carbon. Oct, 8 carbons. It's an alkane, so octane. 8 carbons, 8 times 2, 16, add 2. You get 18 number of hydrogens. 9 carbons is known. For alkane, it has a suffix of A and E, so the name of this hydrocarbon is nonane. If you have 10 carbons, the name is decane. Okay, go guys, do this together with your partners. Raise your hand when you're ready. I'm looking for show of hands. I'm looking for show of hands. Help each other, please. Discuss what you just learned together to come up with the name of these compounds. All right, that's one. I have 2 people. I have 3 people now. I have 4 teams. Yes, 6 teams. 7, 8, 9. All right, guys. Do these make sense to you? All right, please watch the rest of this discussion on video number 2 of chapter 12. Thank you, guys.